of carbon, we have the chemical properties of carbon. We have number one, combustion reaction. Combustion reaction. Can you remind me, what did have I mentioned combustion reaction with you before?
Yes.
Oh, okay, yeah. No, we've not. Okay, I remember. When we talk about combustion reaction, we're actually talking about anything that can burn in air. When we talk about combustion reaction, we're talking about reaction with oxygen. They can burn in air. That's what combustion reaction is. Now we're going to do a reaction now. Let me share my screen. Okay. We're going to do a reaction now. Now, in limited supply, I want to ask you this question. When a generator is placed in a room, what kind of gas comes in? What kind of gas is released from the generator?
Carbon dioxide.
Carbon dioxide? No, not carbon dioxide. If it's carbon dioxide, they won't die. Now, in limited supply of air, this is actually the kind of gas that comes in limited supply. That's why when generator is placed in a room, when the nozzle is placed in a room, what happens? They die. They die after some hours or after some minutes. Why? Because carbon is being released from the generator. Carbon is being released. Now, when they come together in limited supply of air, it releases what we call carbon. It releases what we call carbon 2 oxide. Carbon 2 oxide in limited supply of air. Carbon 2 oxide, that is CO, is released. Now, if that generator placed inside your room could kill somebody, why is it that when the same nozzle of generator is placed outside, why will it not kill anybody?
Because there is abundant supply of air.
Because there's abundance of what?
Oxygen. Supply of oxygen.
Oxygen, correct. Now, in limited supply of air, carbon reacts with oxygen to give carbon 2 oxide. But when it's in abundance supply of oxygen, it releases what you call carbon dioxide, CO2. It releases carbon dioxide. So you should be able to understand the differences between when carbon reacts in limited supply and carbon reacts in excess supply of oxygen. Very, very instructive. Carbon 2 oxide and carbon 4 oxide. All right. Let's okay. Let's continue. Number two, we have combination reaction. Combination reaction. Now, what does combination reaction means? This means that carbon reacting combines directly with certain elements such as sulfur, calcium, carbon reacting with certain elements such as sulfur, such as calcium. Okay, let's write the reaction. That's combination reaction. Okay, now we see carbon reacting with sulfur to give you C2S, carbon sulfide, or we see carbon reacting with Ca to give us calcium carbide. So this is combination reaction. The third reaction for carbon, it's carbon as a reducing agent. As a reducing agent. As a reducing agent. Okay. Now, carbon is a strong reducing agent. Now, when we come to reduction and oxidation, we'll be talking about oxidation in terms of oxygen, addition of oxygen, removal of oxygen, addition of hydrogen. But as a reducing agent, we're going to be reacting iron 3 oxide plus carbon. Iron 3 oxide plus carbon. Now, reduction is the removal of oxygen. That is one of the things, removal of oxygen. So we're going to look at reaction between iron 3 oxide. Iron 3 oxide. Can you give me the formula for iron 3 oxide? Can you remember? Iron 3 oxide.
Fe3O. Fe2O3.
Fe2O3, correct. Plus carbon is going to give us Fe. It's going to give us iron and calcium, carbon 2 oxide. I'm coming, please. What is, let me, iron and let's see, okay. And carbon 2 oxide. So let's balance the equation. Can you balance the equation?
Um, Fe2O3 plus 3C is given to Fe plus 3CO.
Correct. All right.
Yeah.
The next one we'll look at is the third reaction.
So, what do you reckon? What is this
Now,
one?
if you check what we just did,
And this one?
we had we had oxygen in iron, but because it is a reducing agent, it removed the oxygen from iron, making it to be Fe, and now we have 2Fe plus 3Co. Now the next one I want to look at is reaction with a strong oxidizing agent. Reaction with a strong oxidizing agent. And the oxidizing agent we'll be looking at is HNO3. Now remember, when you know oxidizing agents, that means it reduces them. Let's look at reaction with strong oxidizing agent. That's HNO3. Now let's react HNO3 plus carbon. HNO3 plus carbon is going to give you carbon 2 oxide. Please write. I'm not going to write this now. I will just give you HNO3 plus carbon would give you carbon 2 oxide. Sorry, carbon 4 oxide, not carbon 2 oxide. Carbon 4 oxide, nitrogen 4 oxide, nitrogen 4 oxide, and water. And water. Have you written that?
Yes, sir.
Okay, balance equation, please. Are you having issues?
Yes, sir.
Sorry?
Yes, sir.
Sorry, did you say yes or no?
Yes.
Oh, you have issues. Where do you have issues on?
The balancing. I'm taking it.
Okay, let's
Minus
talk
number.
about this balancing thing because I've discovered it's
I
actually,
don't think
sorry? I discovered it's actually taking you time to do that. All right, let's see balancing equation thing. I said HNO3. Okay, tell me what you have, please. Plus,
HNO3 plus C.
giving you
C.
what?
It's giving CO2. Giving
CO.
CO2
Okay,
plus H2O
plus H2O. Okay, plus what?
plus NO.
Plus what?
NO4. NO4.
NO.
4.
Ah, it's not NO4, it's NO2. I said carbon 4, sorry, nitrogen 4 oxide is the same thing with nitrogen 2 oxide. I mean, it's the same thing with nitrogen dioxide. They are similar. So maybe that was where it was confusing you. All right, let's do this balancing. The first thing is this. This is how to go about, or can you do it now? Is this something you want to try again?
Yes.
Okay, try it again then.
2HNO3 plus C is giving CO2 plus 2NO2 plus
Okay, please say that again. Please say it again.
2HNO3 plus C giving CO2 plus 2NO2 plus H2O.
Wait, are you serious? Are you sure that's correct? Please let me write down what you just said. I'm going to write it down. You said 2HNO3 plus C giving you what?
CO2 plus 2NO2
Plus 2
plus H2O.
plus what?
H2O.
Plus H2O. Okay, let me check. Okay, your hydrogen is balanced. Your nitrogen is balanced. Let's check your oxygen. 6 is here. We have 2 plus 4 plus 1. Your oxygen is not balanced. Your oxygen is not balanced. Did you notice that? Sorry? Okay. Do you think it's something we should try together?
Yes.
Okay, let's try. Let's do something. Let me teach you how I do mine. This is how you do. We have what we call left hand side, and you come to the right hand. Are you there? Muna, are you there?
Yes. Yes, sir.
Okay, now on the left hand side, you write down all the things you want to balance: H, N, O, oxygen, and carbon. Now you write H, sorry. At this side, you write H, N, oxygen, and carbon. Now, because you already done the 2, I'm not going to go back to 2 again. I'm going to think of something else because I just saw that with what you've done, 2 did not balance what we want to do. Now, let's try putting 4 here in this place. Since 2 could not balance it, let's try 4. All right? So let's put 4 here. Are you seeing that? If we put 4 here,
Yes, sir.
nitrogen has become 4, right?
Yes.
Oxygen has become what?
So
12. Carbon is still 1. Now, at this place, hydrogen is just 2. So what do we add to this guy to become balanced with this guy here?
2.
2. Oh no, what's this? Okay, we add 2 here. Are you sure you're not distracted?
No.
Okay, we add 2 here. Hydrogen becomes 4. Now, okay, let's come to nitrogen. Nitrogen is 4 here, right? So that means we should add 4
Yes.
here, isn't it?
Yes.
Okay. So let's balance this guy. This guy becomes 4. Oxygen is 12 here. Let's look at this. This is 2. Oxygen is 2 here, making it 4, right?
4.
4
Yes.
times 2, 8. 8 plus 4,
8. So
12. So it's 12. Carbon is 1, right? So it's balanced, isn't it?
yes.
All right. So this is how to balance it. Have you written it down?
Yes.
Okay. Now from here, okay, from here, that is reaction with oxidizing agent. The first thing we talked about was combustion in we talked about combustion in a limited supply of oxygen and in abundant supply of oxygen. We talked about combination reaction with sulfur, calcium, giving you carbon sulfide and calcium carbide. We talked about reducing agents, and we talked about reaction with strong oxidizing agents. Now, let's talk about coal. Let's talk about coal. Did you guys do all these things that I'm talking about now?
He just sends the note on it.
Sorry?
He just sends the note on carbon and its compound.
Or did you guys do all these parts? Did you see that on the notes? Yeah? Okay. Now let's talk about coal. Now, when we talk about coal is one of the two most important or principal sources of fuel and energy. Now, coal is one of the two principal sources of fuel and energy. That was then. I don't think now coal is said to be one of the principal sources because we have too many. Okay, the other one being petroleum. Now, when we talk about coal, is found as a result of chemical complex changes and physical changes. That's the remains of forests buried under the earth millions of years ago under great pressure. Remains of forests, they've been there under the earth for millions of years ago. In the absence of air, what happens? Coal is formed. Now, coal is a complex mixture of hydrocarbons. When we talk about hydrocarbon, can you hear me? Hello?
Yes, sir. Yes, sir.
Okay. When we talk about hydrocarbons are compounds that contain just carbon and hydrogen. Compounds that contain just carbon and hydrogen atoms only. Now, coal is a complex mixture of hydrocarbons and every other organic or inorganic compound. Okay, please write this part. I think I need you to write this instead of me just talking them or just saying them. Coal is a complex mixture of hydrocarbons. Coal is a complex mixture of hydrocarbon and other organic and inorganic compounds. Coal is a complex mixture of hydrocarbon and other organic and inorganic compounds containing small amounts of nitrogen, sulfur, and phosphorus as impurities. Containing small amounts of nitrogen, sulfur, and phosphorus as impurities. Have you written that?
Yes, sir.
All right. Okay, now let's look at types of coal. Types of coal. Types of coal. Number one, we have peat-like coal. Peat-like coal. Peat, P-E-A-T, peat-like coal. Now, right, peat-like coal contains about 60% of carbon. Peat-like coal contains about 60% of carbon. The next one we have is lignite coal. Lignite Have you written that? Hello?
Yes, sir.
Okay, lignite coal contains about 70% of carbon. Lignite coal contains about 70% of carbon. The next one we have is bituminous coal. Bituminous coal. Bituminous coal contains about 85% of carbon. Contains about 85% of carbon. About 85% of carbon. Have you written that?
Yes, sir.
Okay. The next, now, bituminous coal is the kind of is the coal we use. That's what we use mostly for our everyday work. That's for domestic application. They use coal to in coal iron for irons, use it for cooking. They use bituminous coal. The next one is anthracite coal. Anthracite coal. Now, anthracite coal contains about 94% of carbon. Anthracite
94. It's not really. It's not really.
Anthracite coal contains about 94% of carbon. All right. Now let's continue. Now, so we can just see now that from this, the carbon content of each type of coal reflects its rank or degree of classification, and we see it flows from peak to lignite, PLBA. I'm trying to look at an acronym. PLBA, okay, PELBA, 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 PELBA. Okay, I was actually thinking of an acronym. So I think that just came into my mind now. PELBA, PE, which is for peak, L is for lignite, B is for bituminous, A is for anthracite. Oh, now we know the use of coal. That coal is used to generate power for station engines, for factories, for electric parts also. And sometimes coal is also used for making chemicals. All right. Now, I want to ask you this question, evaluation. Carbon occurs abundantly as both dash and dash.
Diamonds and graphite.
Okay, are you sure?
Yes.
Are you very, very sure?
Mm.
Correct. Okay. Let me check. I think I saw another question. Okay, they said describe the combustion of carbon allotropes. Combustion. Okay. All right, let's go to the next one. Wow, we have done. We are moving forward. Destructive distillation of coal. Oh God, I needed to show you a video on this. Do I have a video of this? Don't worry, next class I would show you. destructive distillation of coal. Destructive distillation of coal. Now, what is destructive distillation? Okay, let's write destructive distillation. This is the heating of coal. This is the heating of coal to a high temperature. This is the heating of coal to a high temperature. To a high temperature. Now, put in brackets 600 to 1200 degrees Celsius. 600 to 1200 degrees Celsius in the absence of air. In the absence of air. So when we talk about destructive distillation, you're talking about heating of coal to a high temperature, about 600 to 1200 in the absence of air. All right. Now, please write, during this process, coal decomposes to give. During this process, coal decomposes to give, number one, coal gas. Number two, coal tar. Number three, oh, sorry.
What was the first one?
Sorry, let me just send this part to you because there are some big words you might have issues with. I'm just going to copy this. I'll just send it to you. Okay. All right. Have you gotten it?
Yes, sir.
Okay. Please, I might stop very soon because my battery will soon go off. My laptop is soon going to go off now. Let me just quickly see how I can get your assignments ready before it finally disappears, before this laptop goes off. Do you understand?
Yes, sir.
Okay. Please, I'm also going to send assignments quickly, so in case this laptop decides to go off, we won't be at loss at both ends. If you are done, just let me know, please.
So I'm done.
Okay, okay. Please quickly write this assignment down. Just write this assignment down. Oh, very soon it's going to go off. Let's just go through what we've done because I doubt if it's going to allow us continue now. I have just less than some few minutes before it goes off. Let's just go through them. Please, if you are done, let me know. Constant, but they just took it since. Okay, you're done. Let's just go through what we've done. The goal is not just to finish up everything, it's to know them very well. All right, I'm going to ask you some questions. Number one, what is allotropy?
Allotropy is the existence of an element in two different, in its physical state, but has different forms.
Yeah, the same element existing in different forms. Okay, what is the structure of diamond?
Diamond is octahedral.
And what is the structure of graphite?
Hexagonal.
Correct. Give reasons why diamond is hard and why graphite is soft.
Diamond is hard because the 4 valence electrons are used in bonding, so there's no movement in it. While in graphite, the plate can move, so it makes the graphite to be soft and slippery.
Awesome. I'm enjoying this. Okay, where are my questions? I'm coming. The next question is okay, uses was there. Did I give you? Okay, state 3 uses of graphite.
It's used as a lubricant. When mixed with clay, it forms lead and is used in making crucible.
Okay. Okay, describe with 2 equations only. With 2 equations only, describe the combustion of carbon allotropes.
Carbon plus sulfur give
combustion.
Carbon plus oxygen giving carbon 2 oxide. Then carbon plus oxygen giving carbon 4 oxide.
Remember, you have to be specific and write in limited supply of air.
Okay, in limited supply of air, carbon plus oxygen gives carbon 2 oxide, while in excess supply it gives carbon 4 oxide.
Awesome, beautiful. Mention 4 types of coal and their carbon percentage.
Peak light coal is having 60%. Lignite coal has 70%. Bituminous coal has 85%, and anthracite coal has 94%.
94%, beautiful. Define destructive distillation of coal.
This is the heating of coal at a high temperature of about 600 degrees Celsius to 1,200 degrees Celsius in the absence of air.
List the products of destructive distillation of coal.
Coal gas, coal tar, ammonical liquor, and coke.
Awesome. Beautiful. Okay, so that's where we stopped. We're going to continue next time. Please pardon me. It's going to go off very soon. My phone and my laptop. I'm sorry I could not really charge them, but really we've really gone far. This was meant to, what we just did now was meant to be for 2 weeks. I had to quickly compress them, forgetting all the big words. At least you've just gotten the major things you need. The next time we'll continue, we'll be looking at uses of destructive distillation of coal. Some of the uses, we're going to look at gasification of coke. That's why I gave it to you as assignment. We'll be looking at producer gas and synthetic gas. Those are some of the things we'll be looking at. Then we might need to go into carbon and its compound again, preparation of CO2 gases and every other thing. Then after then, we'll enter into hydrocarbon. Don't worry, when we come into hydrocarbon, that will be the most simplest thing you ever thought of. Do you understand?
Yes.
All right, let us pray. Father, we thank you for today. Thank you for your grace and mercy. Thank you for your love. Thank you for wisdom. Thank you for speed. Thank you for how far you've helped us. Blessed be your holy name, Lord. I pray for your daughter for more wisdom in Jesus' name.
Amen.
Amen. All right. Have a wonderful time.